building context is all anyone is doing if they're using LLMs. In traditional ML, we spend a lot of time constructing features. We crafted, selected, and transformed raw data into a form that the models can learn from. And context engineering is feature engineering for LLMs. And for context engineering, we try to curate input signals. So each piece of context acts like a feature that informs the model's output. And we want to remove noise like HTML tags or unnecessary punctuation. And we also want to eliminate distractions. So we want to trim unnecessary details to prevent the model from getting sidetracked. So basically, we optimize for a high signal to noise ratio. And we want clear focused inputs so we can get better outputs. The second part is we try to give it a structure. So raw data often is messy and unstructured. We normalize it and code categorical variables. We create interaction terms. And for LLMs, we have to transform raw text into structured formats. So we use bullet points, tables, or typelines to break down complex information and present it in a way so the LLM can digest it best. So we are creating structured and meaningful representations of the information. And there are two things I like to think about. First, how would I present this information to a colleague, to a buddy of mine, so he can make a good decision? And depending on the type of information, this is very different. I think like a good example for is like an Airbnb case I've seen once. Like, how could you represent the different information? If I want to showcase like a single apartment, I do it more like a card where I can see a picture, a title, and some key attributes. When I want to allow the user to basically decide between multiple different selected homes, I might make it more like a table where I can quickly scan for selected attributes and compare them across 5 to 10 different apartments. The goal of the user really determines how you should present the information. And also, the task you give the LLM should really determine how you present the information. And you really want to create these meaningful representation. And another question I like to ask myself is, in which context is the answer on the internet? So basically, I give the LLM a bunch of information and I ask it to answer something or to do a task. And what I like to ask myself is like, how does the context look on the internet before the answer is given? And I try to reconstruct that. And the third part of context engineering is refinement. So basically, the feature sets in ML evolve over time through iteration and testing. Likewise, context engineering is an ongoing process. You want to refine your context based on performance feedback to improve the accuracy or the task completion rate, whatever you're going for, of the LLM. So you want to test and tweak a lot, try out different stuff, different prompts, different models. And you want to evaluate how changes in context affect the model output. And you want to use these insights basically to continuously improve the quality of the engineered context. And what, in my opinion, is really important in that you want to make it easy and fast to make a change, test it, evaluate it, and then put it into production. So the CI/CD part in LLMs, I think, is something that's really overlooked at the moment. And the last, balance breadth and precision. So in traditional ML, there was always a trade-off between including too many features, so risking overfitting and noise, and too few, so you likely miss critical information. With LLMs, the context window is really precious. Every token counts. Too much context can sidetrack the model, just as too many features can lead to overfitting in ML. And you need enough information to basically ground the model, but not so much that it becomes overwhelmed by irrelevant details. And the quality of the engineered features in the end often sets the ceiling for ML model performance. And I think the quality of the context sets the ceiling of LLM model performance. if your context is very noisy and contains information that you usually don't see in this, you are likely getting worse outputs as if you clean it up. And we want to transform raw data in really concise, high-fidelity context that don't contain any distractions. So you can get the reliable and actionable insights you actually want. And today we are talking to Robert Caulk. And Robert is the CEO of Emergent Methods. And Emergent Methods is a research lab researching context engineering for LLMs. And they have built AskNews, which is the largest knowledge graph in production. And Rob and I talk a lot about context engineering, but also knowledge graphs and how they can be used in tandem with LLMs and vector search. And we really want to go into how you can get the best results from your LLMs. Let's do it. For me, an agent, the definition goes after like the reinforcement learning definition.
Yeah.
I think agent has become a marketing term. Like in a technical sphere, agent doesn't carry any value anymore. Because if I tell you like implement an agent, you wouldn't know what to do with it. So I think as like technical perspective, like the technical domain, we should scratch the term. We shouldn't use it anymore and come up with like new definitions, which are way more specific. Like what are we actually implementing? Marketing perspective, I think when you're interacting with non-technical people, I think it's always good to have such terms because it abstracts away a lot. They think they know what you're talking about. Everything has something in mind. It won't be what you're actually implementing anyhow, but this is like all the time when you're implementing stuff.
Yeah. No, I'm on board. I agree. But yeah, going back to the RL, I think my definition comes from RL as well, where it's doing a lot of decision making, right? The point of the agent is that it's operating in an environment, learning the policy, and that policy is some functional description of whatever you're trying to achieve. But it's complex, it's hyperdimensional, it's difficult to map. And that's why you need the agent self-exploring in some ways. But yeah, I agree. The abstraction, especially for interacting with clients, it's really important to have these words that just communicate to them that you know what's going on. Because the point is they're coming to you for expertise. They need to hear the buzzwords. It's an unfortunate reality of interacting with clients. At least that's my experience.
Yeah, I think it already brings us a little bit in the direction of like context engineering. What is your experience in having agents like something like QAI or the LangChain agents actually self-construct their context? Are they able to pull from different data sources you have internally and actually pick the right ones with the right queries?
Yeah, it's what level of abstraction should you target when you're developing agents and you're developing some system for building context? I think at the end of the day, building context is all anyone is doing if they're feeding LLMs, because you're trying to extract some insight. You want to leverage the reasoning, the ability of that LLM to actually synthesize and summarize and make recommendations and leverage training knowledge on top of whatever you're building. But what you're building is the context, and that stems from the context engineering. And the ability to build it is hard, for sure. My experience, answering your question directly, my experience is that this is extremely difficult because if you give it too much freedom, it's really hard to quality control. And it's really hard to, especially if you're chaining multiple agents together. This guy fetches something, which makes decisions about what this guy fetches, and then that guy constructs context. Controlling these things becomes very difficult. And in the world where you need strict quality controls and your context requires some adherence to accuracy and relevance, they can go off the rails very quickly. And so for me, usually I try to keep it as simple as possible. And a lot of times that means it's really very basic. This function has one responsibility. It generates this exact structure of information. And then that structure allows me to then go find other pieces of information. I have full control over it. Instead of all of this autonomy, it's a lot more of just functions with a little bit of reasoning. One example, maybe it's better to operate in the example world. Generating a question tree is really good for good retrieval. You want to really maximize your retrieval from a database. The first thing you can do is take a user query and then say, hey, what question tree should I build in order to really flesh out the response? And building a question tree is really a function, but you do need some LLM to just get that tree. But it's not really an agent because it's not super self-directed. It has one goal, and that is to build a question tree. And then you can take the questions and then search on those. So to me, I try to stick to that level of simplicity because it makes things a lot more maintainable, sustainable. It's just easier for other engineers to work with in the future when you need other engineers to come in and maintain it and think about it. But that's maybe there are other companies that are operating on a much higher abstraction level and all of this self-autonomy. But we are focused on delivering very direct news, and therefore it's a lot harder for us to just let things go off the rails. We need to be very regimented in how we report information and making sure that information is strictly adhering to guidelines. And that comes from a lot of very strict function calls.
Yeah. When I have to give SQL, I really, for example, to construct views, because you can actually control what they query and how. You can give clear schemas as opposed to feeding like 10 different tables, hey, and do whatever choice you want. You already mentioned like the context quality part. What are the different technical components of context that you think matter the most for a high context quality?
Yeah, that's a great question. In my opinion, it's about strong metadata and painting a high fidelity contextual picture. And obviously that's a bunch of kind of abstract jargon, but that comes from good metadata. So the stronger the metadata that you give, it seems the stronger the general business insight. And that is, there's some intuition there. It's like this. If I want to forecast whether or not Kamala Harris is going to win the presidential election, let's start with what kind of contextual picture we should be building. Let's say we know Biden exited the race. That gives us a piece of that paints a bit of the contextual picture about what kind of forecast we're going to be making for Kamala winning this race. If we know when he exited the race, when was this reported? That is another piece of metadata that comes in very handy. If he exited 2 days before the election, obviously that changes the forecast 100%. We know that he exited 6 months before. That's a very good piece of metadata to continue to paint the picture. And so if you extend the limit case on that, how much metadata can we add to news reports? What about reporting voice? Knowing the voice that this report was written in, was it sensational, persuasive, objective, analytical, investigative? That gives you a contextual data point of how to take this information into account. Let's say we got 10 persuasive articles about how Russia is the greatest country in the world and it's going to win, and it's very persuasive about why Ukraine should be a part of Russia. That is context, and it is useful, but knowing that it's sensational, knowing that it's persuasive, knowing that it's coming out of Russia, lets the LLM reason on top of that. And then if you start painting the rest of the picture. Okay, how does the rest of the world thinking about this Russian invasion? Obviously, Ukraine is on the opposing side, and knowing what comes out of Ukraine is equally important, and what kind of reporting voice they're using is equally important. You can obviously continue out into all of the countries and continents, and then all of a sudden you've painted this very high fidelity picture of what's going on, and you can make you can then leverage the reasoning of that LLM to forecast what's the highest probability scenario of Russia backing out of Ukraine right now. Russia thinks that it owns Ukraine and it should be a part of it. That tells me that they're not going to back out. Ukraine thinks this. But then you have other countries that are making speculations from the outside about, hey, it looks like there are North Korean troops that are being needed. That's an indication that there's weakness here. But then there's like a demand for oil. All of these little context data points and the metadata associated with them ends up giving you a really high quality, high probabilistic next token forecast. That's at least how we see it when we talk about leveraging LLMs for forecasts.
Do you ever think about how to best represent the context based on the query? For example, if it's more something I have to compare and contrast. So I asked the LLM to compare different Airbnbs, for example. So I probably have a location, I have a description, I have some metrics like square footage, price. So I'm probably best off representing it as a table, I would assume. When I have like events like you just talked about, like the presidential race, it's probably a timeline. Do you have a set of different representations? You basically feed in all the different metadata dynamically, basically like a template?
That's a good question. For our forecasting endpoint, indeed, we make a timeline. So you're ahead of me. Because timeline is a really nice, succinct way to indicate the evolution of information. We make sure that the timeline is in chronological order, right? That's a very small detail, but it plays a big role, especially when you're talking about LLMs that are not great with numbers and you're giving it a bunch of dates. But if you're giving it dates and you're saying, hey, this is the start of the timeline, this is the end of the timeline, you're just helping nudge it in the right direction. Yeah, it depends on the endpoint. It depends on what type of workflow we're trying to give to you. A lot of our fundamental endpoints at AskNews are geared at letting you make a lot of those decisions. We're just giving you the real basic Legos and making sure they're strong, good Legos produced at the Lego factory instead of those like weak, fake knockoff Legos that you might get from one of our competitors. Just kidding. But it's true that the stronger that base Lego, then you can go decide how to format it. All of the winners from the Metaculous forecasting tournament, they're deciding how to use our Legos on their own. They may be making their own timelines. They may be deciding only to take subsets of the Legos. When you were mentioning that, it brought up, I had an interesting thought. If I were trying to be a very generalized task research endpoint, having an agent actually decide the format or configuration, that's nice. That's like a very dynamic approach to context engineering, where you outsource that abstraction to another LLM to say, hey, here's the query, here's the data that we've researched associated with the query. Now you decide the best type of context configuration and format of all of this information that will get me the best answer. That's a pretty interesting idea.
And how do you actually measure the context quality you have? Do you have some internal metrics you're going after or some KPIs?
Yeah, we have this one benchmark. It's called Context is King. And that benchmark is geared at exactly this, evaluating the quality of that context, but it's not that good, if I'm being honest. And I think that the evaluation industry has a lot of maturation to that it will see within the next decade. Part of the problem is it's very difficult to just decide what is quality context and what isn't. A lot of the direction of quality for us comes from research and trial and error and building strong foundation in order to get to good context. But for sure, there's tons of ways to do it. With Ragas, you have retrieval accuracy, which is one side of context engineering. Did you retrieve the right stuff? That's a start. And then you have the accuracy, the correctness is the information inside of that context that you need to get to your final answer. Did the answer come out correctly, essentially? Was it able to actually find the proper information? So those are ways to do it, but it's definitely a flawed, very subjective approach. We try our best to make sure the benchmark is an even playing field, but it's not easy. It's a really hard, really challenging.
What do you think makes context optimized for LLMs?
First of all, I think that conciseness is key. So eliminating a lot of noise. So trying to find the signal before you get to that final call. There's always some final call somewhere. No matter how many additional calls you use to build your context, at the end of the day, you want to get to some final insight, making sure that there's not a ton of noise in that final call. So that means eliminating basic stuff like eliminating tags, even avoiding HTML and raw text altogether, building a concise synthetic picture of that information and being very repeatable in an expected way. It allows you to get really good outputs. A lot of this, the problem here is when you're dealing with dirty HTML and inconsistently formatted information and trying to get them all together, the LLM can spit something out that's coherent. And that is a bit of a pothole, in my opinion, because look like it's made some good insight because, whoa, I dumped a bunch of dirty data in and I got something coherent out. But if you start to look closely, your hallucination rate is going to be much higher. Your accuracy is going to be much lower because some of the noise that you fed in is contributing to that the probability of the next token. That is objectively true. So the cleaner you can make that, the cleaner and more concise the input can be, the better off it's going to be in the end. Not to mention it's going to be cheaper, right? Like your final call is always your most expensive LLM. It's your most high-powered LLM. You're paying a lot per token. You shouldn't waste that very valuable window with HTML tags and ellipses and all of this. The final point I'll make is at the end of the day, these LLMs are just pattern recognition machines, right? There's a probabilistic generation of a token. That's amazing and it can do a lot of things. But if you can build a pattern before your output, a pattern that's clean and recognizable, you're going to catch on to a lot more intuition of that machine than if you just throw a bunch of noise and each token is getting a little bit pulled in different directions just because of all of this random noise. Like the one example I'll give you is HTML is loaded with descriptions ending with ellipses. This is a huge problem for an LLM because as soon as it sees a sentence that ends with dot, it just wants to finish that sentence. Even if it's not doing it outwardly in your output, when it's trying to process all of this information, it's a lot more likely that it's filled in whatever it's thought should go there just because you've seeded it. Wonder what goes here. That's a very dangerous situation when you're dealing with geopolitical forecasts, right? You need to be very clear about what is not. Hey, this is the first half of a sentence. Good luck. That's not a good way to go with. So I think those are some of the methods we find work really well. And that's what we do for people. That is the service. We say, hey, this is what is here. This is what is not. Instead of, here's a bunch of noise. Good luck. That's the biggest differentiation between how we engineer context and how maybe other services are hoping you'll engineer on top of them.
Yeah. One question I always like to ask when I start with that is like, how does the document look like that would contain the answer to the question I'm asking? And I think that's always an interesting mind experiment to go through. Okay, what type of lingo do they use? How is it formatted? And then you can likely already arrive in a direction of how you should construct the context so you can elicit the right responses.
Yeah, that's a great point. And you can even make calls, right? You could have an agent or just another LLM call, and its only job is to speculate. Because what you're doing is you're speculating, which is getting you closer to maybe where you want to be. And that's a little like high DE. I don't know if you've heard of high DE. But this is a
Explain shortly.
Sure. IDE is a method of exploration into a database, especially a vector database, where you take a user query and you try to match it closer to the structure of the document that was embedded. And you maybe even guess at the answer beforehand to get closer to where it was embedded. So if you have a bunch of 3-paragraph embeddings for your vectors about news, let's take it as an example, and then a user query comes in and it says, hey, tell me about Trump and AI. You could embed that 6 words or whatever and into the same space as your 3 paragraphs, but you're not going to be as close. But if you take a guess at what the answer document should look like and then embed that, you're going to get really close to all of the Trump AI documents. Even though this is totally fake and it's completely useless, it's very good for getting closer to your retrieval document, because you'll just it's essentially a glorified term expansion in when you think about the search industry.
Yeah. So for anyone who is curious and wants to look it up, HYDE stands for hypothetical document embedding. I think what comes to mind for me is like what most people forget in like the whole obsession of like chunk size 200 to 400 tokens is, what do I actually want to feed into my LLM? And like, where is the answer? If the answer is likely contained in one chunk, or like in one document, but in a longer document, I probably shouldn't have smaller chunk sizes. I should just embed the whole document and feed it into a longer LLM, a long context one, and not rip that stuff apart. If it's across documents, I'm probably good with chunking.
Actually, on that point, I think those decisions, what you're talking about there, are really where I think a lot of money is made in this industry, right? Because you're talking about how to optimize retrieval for your specific use case. Like another approach that I think is really fun and useful is maybe you do want to chunk and you want to say, okay, I'm going to chunk down to paragraph size, but I'm going to store with metadata in Quadrant or whatever database you're using, Pinecone, Weaviate. I'm going to store with metadata the abutting 3, 4, 6 paragraphs. So when I do my retrieval, the embedding is very accurate, because if you wanted to embed maybe 3 pages, all of a sudden you're losing a lot of data. But if you embed just that one paragraph, that embedding is very representative of at least that particular paragraph. So then I retrieve it, and then I just attach the metadata to it that I've stored with that chunk. And that's really powerful, because then your context still contains the auxiliary information, which almost certainly needs to be present in order for you to make a good analysis. But you saved how much you needed to embed. You saved the actual inference embedding was cheaper because it was fewer tokens that you needed to embed. All of this adds up to potentially a more accurate picture. It depends obviously on your use case, but I think there's so much creativity you can put into chunking, like you're talking about. And that in itself is a part of context engineering, because it's like, how do I get to the information I need? And that's really fun. It's a really cool industry to be a part of.
Yeah. And especially like with multi-vectors, you can do some really crazy patterns, because I don't really have to embed the long document. I can still split it up to 4 different vectors for one document and store it associated with the one document and retrieve over all of those. Where do you actually think, when should people start considering to add knowledge graphs to their search?
I think it depends a lot on how disparate the relationships are between your pieces of information. If you're living in a purely semantic world, it makes no sense to start integrating a knowledge graph. But if you're living in a world where, this piece of clothing is actually, this dress is actually very closely related to this hat because they match. And that match is an abstract understanding that that's your ontology that you need to apply. Then it makes a lot of sense to build a graph, or you might not even need to build a graph. You can use metadata to really start linking things. That's, I think, the more difficult decision to make, because I think most applications do have these disparate connections that need to be established. But the question is more when you think about integrating a true knowledge database, a graph database, is how complex and sophisticated do your queries need to be on these types of relationships? If they don't need to be that large or that sophisticated, you may be able to get away with just using metadata in a Postgres, right? Or in a vector database. So that's, to me, that's where the question really sits. I think most applications need those connections. It's just more about at what point do you need the graph database? And honestly, I think it's pretty rare, unfortunately, for the graph database providers.
And also, I think like when you can avoid it, you should. Because when you start to have a separate database for your knowledge graph as well, you're already dealing with a distributed system, which is something you should avoid at all costs if you can.
I don't know. I'm curious what you think. So does that mean you're against the whole single responsibility principle of development, or?
I believe the whole industry has over-indexed on distributed systems because it is the de facto standard for most things nowadays. But I think machines have gotten so powerful that you can do so much stuff on single machines, and you can also be creative in how you use it, that you often don't need the single responsibility paradigm. And it's like single responsibility. I have one database which handles all my queries. I would say that's also a little bit of single responsibility.
Yeah, it would be nice. A lot of problem comes into place. I don't know. For us, we use a lot of UUIDs, which would violate what you're talking about, where we do have multiple databases, S3 holding a lot of information, and we're tracking UUIDs or RIDs, the IDs that you can actually back out if you just find them somewhere in the world. I don't, at least if you're storing a lot of information, I'm struggling to see how you could store it all in a database. And then you do have to start distributing stuff. I see a lot of people doing even more storage than us, terabytes of storage that they need indexed all and available in a database. And that millions and millions of vectors, hundreds of millions of vectors, that's a lot to store in one location. But I'm not sure. It's tough. I'm watching it closely to see how it evolves. We are a bit closer to the micro deployment world or microservice world where everything has its place. Everything is individually deployable. And that allows us to build what we call the largest news knowledge graph on the planet. But maybe for most applications, that's completely unnecessary.
Yeah. I think when you go distributed, you should have a clear reason for it. And I think a lot of people don't. And I think a lot of people start with complexity instead of starting with a simple system and then evolving it over time. When I need the performance, I need the extra reliability of a distributed systems. And I think it's often because a lot of the tutorials, a lot of the resources out there are from big tech or from people who worked at big tech. But their needs are very different from what most organizations need.
That question, I think, is what makes or breaks startups. Is I see this on LinkedIn and Twitter all the time, this whole idea of don't over-engineer too early. Hack it out. Get something out and see if it works, and you'll re-engineer it again once you have a full crew. You'll probably break it down and start from scratch. So starting with microservice-oriented paradigm might end up giving you baggage because you started too early. On the same note, if you're convicted in your application and you're building it out, so choosing tech debt from the start, right? When you hack something together, you're choosing tech debt because at some point you're going to need to pay that debt. That could slow you down at a very pivotal moment in the development of your startup where it's like, oh, we just blew up. We're ready for our 10,000 users per hour to serve them. And they're trying, but this system is just completely falling over. We're going to need to block and pull back to our 200 per hour that we were able to serve before and rebuild. And then in 6 months, let's just hope and pray that those 10,000 per hour come back. I don't know. That sort of decision making is so abstract and so difficult. It's project manager level stuff. Even I consider myself not capable of this level of direction. I usually move more towards, let's engineer it right. Let's build the test. Let's think about the future. Let's think about scale. And that has paid off for us, but we definitely don't move as quickly. We're as if we had just straight up hacked everything together in a big mono repo and just said, click play and just hope for the best. But I don't know. I think there's a lot to learn in the industry.
I think as a startup, you have to pick your places where you want to over-engineer. What is the thing that makes you special? And I think in that you can over-engineer, but in the rest you shouldn't.
It's true.
And also, like, where do you have experience with? What is the tech stack you have built with before? This is likely also the tech stack you should continue building with. Because when you're building a startup, you don't want to learn at the same time, like how Kafka, for example, works, while you're building your entire system where you should focus on the business problem you're solving. So you should pick and choose your battles. And I think also there are so many really good managed services out there at the moment, which you should probably pick as a startup. Because when you hit the scale, it will cost you, but you can still serve it.
That's true. Yeah, choosing the managed service route, that's also something we struggle with. We love self-hosting. And whenever we do choose to take a managed service, it took a lot of bending over backwards fighting our instincts to say, listen, this is not something we should be worried about right now. Let's stop spending 10 hours of engineering per month dealing with this and move to the managed service. This is one reason I think AI is not taking over anytime soon. Some of these decisions that we're talking about here are so abstract and so broad and wide and require so much context beyond what can be found on the internet that the whole idea of the AI CEO, to me, it's a complete moonshot and it's not going to happen for a long time. I'm curious if you agree or not, but this conversation is evidence of it, I think.
Yeah, it's for me, like around tech stack decisions, there are so many tools out there that I wouldn't trust an AI to do it. Because I think based on whatever I'm building, where I'm building it and what for it, and also what do I have in my team in terms of skill set, it all steers me into certain directions. And I think all AI, all LLMs have certain biases, which in my opinion are being trained in. Like Gemini probably will favor Google Cloud.
It's smart.
OpenAI will favor Azure. I think you will encounter more and more biases when it comes to that. They will recommend their own stuff. And when you're building a startup, yes, it is the easy path of just using it, whether it's when you're building anything in tech. It's the easy path, but whether it's the right one, I wouldn't say so.
Yeah. Yeah, I agree.
Where are the places where you actually went with managed services? I'm really curious. Like Quadrant is one. You already talked about that before.
We self-host Quadrant because it is big and we have our own cluster. And so that means that we do a lot of hosting, but we also have a cloud cluster. So we use DigitalOcean managed Kubernetes, which is really convenient. And they have a great S3 that we use. We have a couple databases. GitLab is a good one. Dealing with runners and stuff, we've done it for a long time. And we even still do run GitLab runners. But at some point, you might as well just outsource that sort of stuff. So yeah, I think those are some of the key spots. I'm trying to think of some others here. We still use we do a lot of both. We self-host LLMs. So we self-host Llama, we self-host Phi3. But at the same time, we're also outsourcing services to Anthropic and OpenAI and even Fireworks to help offload extra bandwidth in certain cases to get higher quality in other cases. So those are some of the services that we'll link into.
And because we already touched upon it, I'm really curious about the knowledge graph to Quadrant, the architecture behind it. Like, how are these two components connected and integrated? And especially when I'm thinking through like a query of a user, like how does it flow through them? Where actually does the knowledge graph begin and where does it hand over to the vector database or vice versa?
Yeah, there is it's a hierarchy of services that are talking to each other. Quadrant is handling the entry point, right? Quadrant is this really beautiful system where it's able to get you that general regional overview of what you're after. In this particular case, we're looking at all of the news. And so to start, we need to at least get a general region, because there's no way we're going to host and upsert 1 million entities per day into a graph database. Instead, you can start with a vector database, right? And that vector database is really powerful at searching through hundreds of millions of vectors and then filtering those vectors upon nodes, right? And then basically your node types. At the end of the day, a knowledge graph is simply metadata with node names and then the relationships between them. There's nothing stopping you from using a Postgres or a Quadrant to just store metadata. Even in NoSQL, MongoDB, just filter on and index the parts of your graph that you want to gain early access to before even the graph is constructed. So this is basically the entry point of the query is, hey, let's at least narrow it down before we get into the nitty gritty of multi-hop querying and applying Cypher in some way, some kind of sophisticated way. So at least that gets you access to a lot of the information. A lot of this are just UUIDs, like I talked about earlier. And so some of the data is not necessarily stored directly in Quadrant. And so that also makes things a lot faster and more efficient, because again, you don't necessarily need all of that information sitting in RAM. You just need the indices sitting in RAM. With Quadrant, those indices can sit on disk, which is really powerful because it opens up the ability to make massive indices without paying an arm and a leg. So some of those indices are absolutely helping build out the final graph. First, we're aggregating a bunch of information using Quadrant S3, and then able to then build a graph on the fly from that information. And so that graph, when you're building it, that's the more complex part, the part that we've put our research into, how to build that graph on the fly in a very A, efficient way, B, accurate way, and then once you have that, you can upload it into a graph DB, because now you have this small graph. It's really agile. It's really mobile. You can upload that into whatever you want. You can put it into memory with Kuzu. I don't know if you heard of this, of Kuzu. Or you can put it into memgraph, which is really powerful, or Neo4j, whatever you want. Because now you just have your triples, right? We've gotten the triples, but in order to get to that subset of triples, we had to take this kind of journey. And I don't see any other way that you would go about doing something like this, because again, you can't just upsert millions of entities a day into a graph DB. They're very heavy, computationally expensive. They're not designed for this sort of thing.
Yeah. I would love to make it a little bit more tangible. So I'm like a user. I have the question,
Sure.
Is Kamala Harris going to win this election? Yeah. We know it by now, but the query comes in. I'm assuming you're searching over some form of document.
Yeah, then we can essentially do that query into the vector database, into Quadrant in this example. So we say, okay, I want to know about Kamala Harris for the presidential election. Okay, query Quadrant, get all of the related documents to that. Now, there are multiple ways to query AskNews. If you want to just use the natural language query, you can. If you did want to attach other metadata filters, you absolutely could. And in that case, let's say I wanted only Kamala, anything about the Kamala in the presidential race that mentions Putin. Let's go with that, right? Because that would be your start of building a graph about Putin and Kamala. Because let's say you want to get all relationships between Putin and anything Kamala related. The step there would be to actually fetch all the documents that mention Putin with respect to Kamala. So that's essentially, we're able to get those documents first and then build out a graph related to that. Does it make sense?
Yeah, so basically you have embedded, for example, all the news items. I'm running my search over it, I'm getting the documents, and then I'm constructing a graph.
Exactly.
But how does the graph actually now come in? What value does it give to me? Why am I not just returning like the top 100 documents and say I'm done with it?
Depends on your context engineering and what you're after, or it depends on if you even need a graph. The graph can come in handy in certain circumstances. Again, because let's say I got 1,000 articles in this region, and now I do want to start doing complex Cypher queries. Okay, now I have my triples, I create my graph, my on-the-fly DB, and now I can actually query it with Cypher and do, okay, I want all relationships, that all of these types of relationships within 2 hops of entity X. That's a sophisticated Cypher query that you cannot do with a traditional Postgres or Quadrant or something. So if you need to make that type of query for your extraction of information, then you would need that. But you don't need to. If you don't want a graph, we don't need to build you a graph, right? Essentially we have a pipeline of enrichment, and you can dip in at whatever level of enrichment you want. But if you just want the raw, you want to treat us like a typical news API where you just grab news docs out and you're on your way, great, no problem. If you want us to construct your graph for you, no problem. If you want us to construct your graph and query your graph for you, no problem. So essentially that enrichment pipeline allows people to select what they need and when they need it.
Yep. What would be a good example for a query where you actually have to construct the graph, query the graph, but then also, I'm really curious also about the re-ranking part. Like, how do I then combine the different signals from the graph, from the semantic search, and probably also the keyword search, which you're running as well?
Case of our graphs, of our news knowledge graph, would be an analyst trying to explore relationships of some topic of interest. They're trying to, here's an example. Love Justice is an NGO in South Africa. They're trying to combat human trafficking. One of the ways to do that is to identify entities which have cropped up in relation to crimes that maybe are related to this topic. So they can build a graph out and go select that entity, but then get 2 hops to that entity. And all of a sudden, now you've got semantically different information that's related to it, which allows you to identify a hidden relationship, right? Because let's say a crime occurred at this shop. And so they managed to uncover some crime at this shop. That's in the news. There's another article somewhere that mentions that this shop was struggling to get supplies from this organization. And then that organization has some crime associated with it. And all of a sudden you've managed to potentially connect dots that were not immediately apparent by just doing a similarity search on that initial shop. So now you've basically identified that, hey, this is interesting. This organization had a crime that may have a connection to this other crime that occurred at this shop. And I could only get to that by this knowledge graph. Does it make sense?
Yeah, and I think you could probably do it both ways. Use it to enrich, but also use it to basically narrow it down because the relationships aren't there that you're actually looking for.
Yeah,
what I'm really curious about, we talked about in a conversation before that you basically normalize everything to English. What I thought about
Kind of.
immediately is
Yeah.
how do you handle entities or relationships or concepts that do not translate well?
That's a good question. So we are tracking, I think, 17, maybe 19 languages now. And we only track languages that we know can translate well. Now, that still doesn't technically answer your question, because you said maybe the majority of Russian translates well, but there are certain entities that just don't. They don't translate. And the beauty is, if it doesn't translate, a lot of times it won't translate an entity name, right? And so we can still have that original name in the database. And especially if it doesn't translate well, it's probably just going to keep that original name. There's no other way there's nothing else that it can do with it if it can't translate it. So we can still hang on to entity names that are in other languages, which is great. But when it comes to text and stuff and expression of information, there's absolutely some information lost. And that's unfortunately kind of part of the game that you're playing. If you want good search, you want good relevant search across French, Swedish, Russian, and Italian all at the same time. I want to say, give me all of the latest information from all of these languages related to the European politics. You could go in and try to do multilingual embeddings, and then you have multiple vectors potentially, or you have one embedding model that you think is great for just those languages. It's going to get messy fast. But if you've normalized everybody to one language and then embedded, now you're operating in a much cleaner parameter space. At the end of the day, we're just talking about parameter spaces. And that parameter space is, hey, my Swedish report on European politics is now sitting in English. My Italian report about European politics is sitting in English. And therefore, when I make an English query, those things are coming out equivalently. We've now reduced bias, right? So we've mitigated some bias towards a language because we're not actually biasing to a language. Yes, in general, we're sitting in an English translation bias, which we fully admit, okay? But it's one of the better bias languages to be sitting in, since a lot of the LLM world is operating in English, and prompts are very receptive when you start interacting in English. There are absolutely sacrifices to answer your question directly, but in some cases you may be surprised that if it doesn't translate, we're just holding on to the original entity name. The rest we get as a nice, balanced retrieval.
Yeah. And to really drill that home, I built something similar once, and I tried to do it in multiple languages. And I spent nearly a month trying to get entity deduplication to work. Because you then, if you have basically multilingual entities and relationships, you basically have to know, okay, which entities and relationships are basically equivalent and which are not. And when you're dealing in multiple languages, it's significantly harder than just in one when you're already in English.
So disambiguation, the deduplication, which is actually slightly different than deduplication, is currently a research topic for our laboratory, because we are just an applied research lab. And so we're doing research on these topics and injecting it into the tools. And that's part of the offering. It's, use our service, and then you benefit from all of our research. One of our research topics, I think it was at least a 3 or 4 month research stint for 2 researchers, was how to best disambiguate across multiple languages, across different topics, right? It's not even just languages, it's topics. And what we found is that, we found a really nice method, which works very well the majority of the time. And so that is the default approach that you'll get when you interact with the knowledge graph. But you still need human in the loop interaction some of the time. And it may not even be because we were wrong. It may be because you, as an analyst, want these two things disambiguated, even though there's no reason beyond your particular use case to disambiguate them. So we need to give you, as the user, the ability to then correct the disambiguation or constrain the disambiguation. So that's part of the tool, is like me as an analyst, when you use our Newspunker dashboard, we'll build your graph for you right there. You're visually looking at it. And okay, for my particular use case, I've got Trump here and Elon Musk, and they're separate nodes. But actually, for my use case, I want them to be the same node, because I just want all relationships that touch either Trump or Elon Musk in this case And so I'll just disambiguate them as the same thing, right? So that would be a perfect, or your particular use case. But our system would still disambiguate automatically President Donald Trump, former President Donald Trump. All of that will turn into one node already based on our research, because that's about the extent of where we can drive that disambiguation. But if you then want to pair Melania with it, or you want to create Trump family node or whatever out of all of them, then we make that functionality available to you, because that's just what analysts asked for, right? When we were building it, a lot of the tool is just because analysts needed some functionality.
Yeah. And a lot of that comes also into play with entity recognition. And what I'm really curious about is, how do you handle new domains? So just as an example, I haven't handled any legal publications yet. So I'm suddenly integrating legal news into your knowledge graph. The entities that it extracts and also the meaning of the entities is likely wrong, or is different from what you've already seen. So how do you handle that?
Yeah, I love this question. So first of all, there's like a tiered response to this, and we've solved it. That's why I like the question so much. First of all, let's start with the model that we trained for entity extraction and released on Hugging Face. Is called Gliner News. We fine-tuned Gliner, which is a very smart architecture based on BERT. Now, this architecture allows you to, or it has extrapolative abilities. That doesn't mean that it's able to perfectly move into a new domain, right? Of it's never seen law, and now it's able to do law without seeing it. So you're right. Your intuition is 100% on the head of the nail. But if you have trained it for a variety of topics, it is very good at extrapolating. And we proved that with our research paper, and I can link you to it. It's called Curating Synthetic Data with Grounded Perspectives for Equitable AI. And the whole point is, how do you train an entity extraction model to be good at extracting across a variety of topics, a variety of countries, a variety of entity names, right? Law, sports, Kenyan organizations, Chilean business names, and Brazilian political names. The only way to really prepare your model for new incoming entities is to make sure that it has seen as a good representative sample of the world. So in this research that we did, which was probably more like 6 months of research, it was, how do you engineer that underlying data set to be representative of the types of topics that you expect to encounter when you are actually deploying this entity extraction model? And so essentially, we have very good diversification techniques across topic and continent and country and even PageRank, and trying to really dive deep into the diversification. Again, fill out the parameter space that we're planning to operate in. And that works really well, especially if you use the proper disconnect between your train, eval, and validation data sets. If you don't have leakage, your eval and validation are actually going to give you some insight into how this thing is going to perform on entities it's never seen. Part of what we split on between these data sets is time, because that's where you'll see new entities arrive. And luckily, since we've engineered the context well in the past, we can split on time wherever we want. And that enables very powerful training and very strong conviction that this model is going to be able to adapt to new domains. Now, the second part of the answer beyond that is that we retrain it on new information. So every 6 months, we're retraining just to make sure that the latest entities in the news are in the training data, because that makes it even better at entities it's seen before. And it makes it more prepared for more similar entities that might be entering and new topics which are becoming more and more important. For example, when we trained the initial Gliner, we certainly did topic diversification, but there's no doubt that there's a large percentage of data related to Ukrainian war, Israel, Gaza, right? These are topics that were present, and that means we're going to be good at extracting any entities in related to those topics. But as new topics, new, hopefully not wars break out, but new general trends and new ideas and subjects become more prominent, we adapt. So that's the second layer of it. We retrain and redeploy. And so now when you're using our system, you don't have to worry about any of that. You get all the latest entity extraction. You can rely on the quality of what we've built because we're using our own models. The final point I'll make is this model was top 10 downloaded model in 2024. So I think we eclipsed like 8.5 million downloads. And that's not because people care about diversity. It's because it works, right? That's it. Like the way we approached the training of this model means that it actually works very well. And there's a lot of need for entity extraction. And news happens to be a really diverse representation of information. We've got science about bio, science about mathematics, right? People report on all topics. And so you have a good vocabulary, base vocabulary there. So it's called Gleiner News, but it turns out it's really usable across almost all domains just because of the nature of the topic diversity and how we've injected it with the news.
If you have the time, I would have 2 follow-up questions on that.
Go for it.
It's maybe first on the continual training. How do you actually approach the training mix? Because there have been a bunch of studies on that, like what's the optimal mixture? And I think it's still pretty unknown. I think Predibase always, or it advocates for basically 50% from the old training set and 50% of new data to not bias it too heavily. Do you have anything, any tricks?
We have some configs that we've learned works well. A lot of what we do is human in the loop looking at data, right? This is one reason things work for us is, we use evals. We even track general benchmarking data sets while we're training. But at the end of the day, sometimes it can do well on a training, but if you go look with your own 2 eyes at a lot of the output, you may not actually be as impressed or happy about what's happening. So a lot of what we do is we look with our own 2 eyes. And when I say we, I should say Ellen, who's our director of transparency research. This is transparency research at its finest. Looking at it with our own 2 eyes. And that means, taking the data, looking at statistics about that data, visualizing various dimensions about how it's represented, where's the error, looking at the error itself, identifying where the error is and deciding, is this error that we like or don't like? Why is it error? Sometimes it just crops up as error in your training, but the reason for the error may actually not be as bad as you think, or it may be worse than you think. And so you need a human to just go in and look. And so at the end of all of that, we end up with a config and we say, hey, this is the split that worked at the end after all of our retries. This is the heuristic we're using for our splits across diversification. Like one decision, I'll give you an example of kind of an arbitrary decision that just had to be made. We just don't have the same amount of data coming out of Kenya as we do of UK and France and USA, but we still need data. So how do we decide the amount that we can't break down the United States all the way down to the same amount of data from Kenya? We'll lose a ton of data, but we don't want to bias too much to the United States. And so this comes down to a bit of a, hey, we think generally we're going to cut off these major countries at this percentage and make sure that the tail is smooth and that, Bangladesh, we have a very small representation, unfortunately, but at least we're guaranteeing that the distribution fits what we would expect the general representation to be from a just reasonable human being perspective. And then it ends up working when we apply it to Kenya, right? Checking. Okay. Kenya didn't have a great representation, but when we apply it to the Kenyan information that it hasn't seen, how well does it do? A lot of the decisions are kind of art in some ways, which I hate to say it, but that's a moat, right? We couldn't find real hard quantitative solutions to some of the questions you're answering or the questions that you're posing. And the fact that you're posing the questions indicates that you're locked in, like we should probably hire you to start working for us at some point, because those are the hard questions to answer, honestly.
Maybe another hard one. How do you think about like slop? So basically the AI generated content that probably doesn't carry much signal, doesn't carry any diversity, and also isn't really fresh.
Yeah. We deal with this a lot because a lot of what we're doing is scraping open web information. And some of that open web information is indeed slop. It's just total AI generated crap. I don't know. There's a bit of a philosophical debate here about if it's going to break the internet, right? I think that's what everyone wants to know. Are we going to just deteriorate into this idiocracy of AI generated madness? And I don't prescribe to that mentality only because people are directed towards information that they buy. They not buy like physically, but they agree with, they resonate with what's being described there. And I don't see people resonating with AI slop ever. And so that content doesn't generate value anywhere. And therefore it doesn't warrant its existence on a server. And really it costs money to hold a piece of information on a server on the web. And if it's not generating value, it's not going to sit there very long, unless it's getting traffic and generating value. So I think a lot of that slop is just always working its way out of the system. Unless someone really wants to waste money hosting a ton of slop, I'm seeing still a lot of great writing coming out of a lot of places. And even we, as a company that uses AI, we hire human writers because you need a human. If you're trying to generate a piece of writing that hasn't been generated before, you can't use an interpolation machine to get to that answer. You can use an interpolation machine to help get you to that output, but you need a human to connect that dot between what I as a company want to express or an organization and what I as a person believe the audience is ready to read. And I don't see slop connecting those dots anytime soon. And that to me gives me comfort that, okay, I'm paying writers, so I'm going to be still contributing to normal writing. And we are AI first company until we see some true slop like overload. And I'm at least optimistic, but what are your thoughts on that point?
I think it will become more and more content. And I think it's the same as it was before. Our recommendation systems are very good. If you decide to engage with slop, you will probably get more slop. And you create your own echo chamber. And I think you have to curate. And the value of curation probably will go up, but it already is. Like the amount of content that's already created, probably a factor of 10 won't make much of a difference for the singular person. For me, like when I'm writing stuff, it's like my quality bar is basically I take all the context I have, throw it all into Claude, Gemini, whatever, and give it like really instructions how to write it, what to write. And when it gets close to what I've written, I just throw it away and don't publish it.
When it gets close?
Yeah, basically.
In what way?
So I have written my blog. I'm finished. I don't really write with AI. Maybe for some phrases and stuff and rewriting. And there, I feed all the input into the LLM. And when it gets close to my writing, I just throw it away because I assume it's nothing new.
Interesting. Okay. Because it's managed to, it's only interpolated. So you're on my side of the fence of if an AI was able to interpolate to it, it's not interesting enough for the web. Interesting. Okay. I like that. I like this. I'm going to share that anecdote because I think that's a really good test. And I had not thought about using that as a test.
It's an interesting quality bar, I think.
That's cool. Interesting.
Nice. So what would you say? What do you think is missing from the AI and data space? What would make your life way easier if it would exist?
As a consumer, myself?
Consumer, developer, business person.
I'm still not seeing, maybe I'm not seeing it, but the interaction with the repositories is still not at the level that I think I would like or need in order to expedite my process beyond Copilot. Like Copilot is great. It gets the job done for a lot of things. It expedites the workflow. But I think a much deeper understanding of the repository is something I would love to see. Something where I'm able to onboard an engineer very rapidly into a very sophisticated set ecosystem of repositories where they can talk to them and ask questions and get real answers. I think a lot of questions when you're talking to a repository, I've never gotten great answers out when this whole idea of talk to your GitHub. It's always kind of something that satisfies what you're after, but it's not really getting to what I need, and I end up searching myself and then solving it. I would love to see an engineer be able to onboard and actually talk to a set of repos and get that out. Maybe it's happening with a product that I've missed. I think AI is moving quickly. So I don't know if you know of one. I'm happy to get recommendations.
I don't. It's two thoughts on this. Like how I do it, I go through the commit history and the issues and look at how the project has evolved. Because often it concentrates on certain area where there is the most activity, and that's the most important one. So you should probably focus your attention there. The second part is I think we need coding tools that behave more like systems.
In what way?
We have a lot of different components already. We have good code search. We have tools that can answer questions decently well. We would have tools to construct context, but no one, in my opinion, has put it together in a good way. And I think you have to construct it as a system, because I think this also evolves into like how agent would probably use it. Based on a query or like a task I want to do, first I should decide, okay, what do I actually need to do here? Do I need to search, or am I just writing boilerplate code that I can just use the LLM and generate immediately? When I'm asking conceptual questions, you probably want to pull in additional context from the commit history, from the issues, from discussions in the forum. And I think you have to basically have different components, like microservices architecture probably in the end, and you're pulling them in on demand. And I think there is no tool out there yet which does that. And I think in the beginning, it will look like a workflow. You probably have a classifier, you have 4 or 5 different workflows based on the complexity of the task or the type of questions, and they are executed. And over time, it can become more and more agentic. But I think that's really missing from coding tools at the moment.
I like that idea of using commit history and context. And I can see how going and finding the relevant commit messages themselves and appending that to and saying, hey, here are the commit messages, here are the commits. I can see how that can help. Maybe we need proactive context engineering. So what about this? What if we took basically as you make your commit, you type your commit message, but at the same time, as you submit it to the repository, an LLM ingests it and then fleshes out a much better description of what occurred in that commit. And maybe even, I don't know, it does some other indexing across different metadata points of this repository and this branch, edit, those sorts of things. So then it's like proactively engineered the context. So then when in the future, when I want to talk, I can now talk to a lot more sophisticated text without even getting to that code. I don't know. Sounds like something we should build.
I think there are a few who do like this automated commit message construction. I'm using Better Commit, the tool to write the commit messages. And it basically forces you to decide, okay, what scope is it? Is it like feed, refactor, performance? And then write a description, write a title. I think like the description is the biggest part, because that's the biggest annoyance.
I never write descriptions. So that would be great to have.
As a second part, I think is how can we actually make it easier to find the right stuff? And I think what I have gotten into is when I start a new file, the first thing I'm writing is a doc string at the top. What I actually want to do and what the interface should look like. And this is something that helps a lot. Like I often don't even need to like pull in any additional stuff into the context window because I've already written it out. And I think like these like commenting more, not for other humans, but for LLMs. I
Yeah.
think this is really not the practice we should do for humans because it gets a little bit annoying. But like comments for LLMs to actually help them generate the right stuff is a really interesting habit to get into.
I wonder if some of the tools go in and auto comment repositories, like a tool for talking to a repo. I could imagine that during the initial indexing, one strategy could be for the LLM to go into each file, each function, and itself make a little description of what this thing does for future LLMs to then come interact with this like more indexed repository. Maybe that's one way to do it.
I'm not sure about that because what it does should be obvious from the code I've written. I think you should document the decision making behind it. What have I already tried? Why am I choosing to do that? The why and not really the what and how. Because code is a way more precise language than regular language.
Yep.
What you express in your code should already explain the what.
And the why is something that AI will never be able to do, which is interesting. So yeah, maybe you're right, that level. If we start training engineers to be a lot more careful about the why in the commit message, in the description, and in the comments, the LLMs can fill in the rest of the dots, right? Like you said, everything else is easily filled in, but the why, that's the project manager that you're trying to build into the system. Why did we actually make this feature? Then if that context is very powerful extra dimension that I honestly had not thought of before this conversation, that for sure, if the LLM has the why, it's able to reason on top of it and therefore probably make pretty strong suggestions about new features and potential bug fixes because it knows the thought process of why of the external context of why a lot of this information came into being. It's like it's like basically root context engineering, like making sure that your context has a root into the most important humanitarian root of the context. I don't know. I haven't thought about this, but I want to try to find a way to get this into the news. This idea of like, why was this news written? Not what is the news, but why was it written?
Yeah.
That would be really nice to have.
What's the motivation behind it?
Yeah. That honestly will open up a lot. And in some ways, we can build those sorts of tools, and there are organizations that focus on where money comes from, money talks, but those data points are hard to come by. So context engineering is hard. Let's put it that way.
Maybe on that vein, what's next for you guys? What are you building on that you can already teaser?
We're about to release publicly alerts, where you just naturally describe what you want to track. And then you say, hey, alert me if a protest breaks out in Paris and send me a Slack message and a Discord message and fire me off an email. And then in the background, we start tracking the news to see if a protest broke out in Paris. And then as soon as it does, Slack messages and emails go out. We call it natural language alerts, and we're really excited about it. So that's the big teaser.
Yeah. It's at the moment a little bit of a pet project of mine is basically an event stream where I have a vector search running on top of and like vector search, rule-based classifiers and stuff like that. I'm trying to build it out, but it's a really interesting topic, basically Kafka, but for unstructured data, like stream analytics, but
what's the data source? Where's the data coming from?
I'm just mocking it up at the moment. So I'm just using basically different RSS feeds.
But news generally.
Yeah, news generally. It's like mostly technical news, technical content, and trying to get notified when something pops up that is of interest to me. And I think it could be used in a lot of different areas and ways. But the technical aspect behind it is really challenging because Stream Analytic operates mostly with really simple queries, which can be expressed in pretty basic SQL. And it's like doing it on unstructured data, and especially unstructured data that is very large, like news items, blog posts, is a little bit more of a hurdle.
I should let you hook into the system to see if it helps. But yeah, no, that's a big aspect is like, how do you get to the content? Basically cost. How do you reduce the cost of tracking the news with an LLM? That's more or less what it all boils down to. Because you could feed everything into an LLM and just keep asking it the question, has this occurred? Has this occurred? But if you do the right context engineering with the right retrieval and you've processed the information properly, then it starts to become a lot cheaper. And that kind of goes back to that processing pipeline. And so I'm happy to geek out in a future session about how to do event tracking.
Yeah, I would love to once I get it working completely. Nice. And if people want to follow you, check out what you guys are building, or use it, or follow your research, where can they do that?
Yeah, so the company is Emergent Methods, and we have a website, emergentmethods.ai. That's where our research is located. The data source is called AskNews. The context engineering as a service, that's asknews.app. So, head over there. We have our own editorial. We have an editor in-house. So we believe that the content that we produce is the least biased in the world, and it's a nice global news tracking. Check that out. But we're also on LinkedIn, where you can go to Ask News on LinkedIn and Twitter and stuff like that. But thanks for having me. I appreciate the chat, and the questions were a lot more sophisticated than I expected. So I appreciate that.
So what can we take away if we want to apply that? I think in general, building an LLM project is first about getting the basics right and then iterating until it's good enough. So the first step should always be define your problem, and you should spend a decent amount of time there. What is the problem you're actually trying to solve? And then go into the data, examine and label the data, and manually answer it. So manually go through a few inputs and actually try to derive the correct answer, and not even derive like a solid one, but like a perfect answer. And if you can't do this yourself, get an expert to help you, and try to also understand his thought process. Like, what are the actual steps he's going through? What are the specific items he's looking at? And really make him explain his thinking and note it down. And also try to uncover, okay, what is the additional context he is using when he is creating his answer? Like, what's the context that's not on the page, not in the input, that he has, but you or the model doesn't have? And this allows you to really understand, okay, what's the data quality I'm working with? What are gaps in the input data, in the context, that I actually have to fill? Because if he has the necessary context in his head, the model doesn't. So we need to fill it. So we need to figure out a way, how can I give the same information that the human has to the model? And then try to identify like the key feature, the decision points, and also like the different steps he's walking through. Because if you can solve it one shot, this will allow you to basically break it up into several steps, which in sequence solve the overall task. Then the third step is already like clean and engineer the context, like test it out a little bit, create a basic prompt which takes in the input data, but already spend a little bit of time actually thinking through the pre-processing pipeline. Like, how do I want to change the appearance or the format of my data so the model can make a good decision? And also try to like strip out some noise and format in a way that makes sense. If you have chronological information, do a timeline. If you have just general information, use Markdown. If you want to compare and contrast, use something like tables. And then you can actually move into the actual model selection and fine-tuning phase. And fine-tuning, I don't mean actual fine-tuning the weights, but rather adjusting the prompt so it can generate a good output. So pick an LLM that fits your needs, and often you have additional constraint in here that actually determine a lot. So for example, if you have a really high concurrency, you're likely stuck with OpenAI and can't really use Anthropic. But for things like coding, for example, 3.5 Sonnet is just better. And use your labeled examples to actually test different versions of the model. And what I start with a bigger model. Like nowadays, this would be something like O3 Mini. I test it, and then I would think about, okay, if it is going really well, I actually move down. So I use the same prompt, the same input, and use, for example, 4.0 mini because it's way cheaper. And when I can get the task done with a cheaper model, I will do that. And this will basically already allow you to test, experiment, and fine-tune the prompts. What you will likely encounter is that the model isn't able to solve all your input examples one shot. So you likely will spend some time adjusting the context and the prompts. And here really try the different context engineering techniques we talked about. Construct the context in different ways. Construct tables, construct timelines, construct markdown, add additional instructions. Okay, think step by step and detail the steps that you've got previously from your conversation with experts. And tweak it until you find decent enough results. If it really takes you a long time to get it in one prompt, you likely have to decompose it or add a few shot examples. If you use few shots, I would always be a little bit careful that you have also examples in your test set that are not too similar to your few shots, because then you can actually be a little bit more sure that it can extrapolate to what it will see once you put it into production. And after that, it's basically just iteration and evaluation. So test your model continuously, make tweaks, evaluate it. When it performs better, put it into production. In production, monitor the outputs, flag cases which might be wrong or which might be correct. If you can collect user feedback, try to figure out a way to make it easy so that the user can give feedback, even if it's implicit. So often, for example, for ChatGPT, I think a really good signal is if the user copies out the data. So if you can figure out something like that, I think that's already a pretty big step that you can automatically evaluate, okay, what are really good outputs and what aren't good outputs. Also, like if you have a chat application or if you have anything where it's more like generation based, if he regenerates, like this is already a pretty bad sign, like the output was garbage, and you can already flag that for human review as well. And through that, you basically collect new input output examples, which you already flagged with like positive and negative, which you can add either to your test set or which you can use to tweak the prompt and see whether you can improve your overall system. And lastly, plan for the deployment. Think about how you will actually serve the model and where, what additional things are necessary. For example, if you're based in the EU, you likely have to set up something like Azure, so you can use the models that are actually hosted in the EU as well to comply with all the regulations we have. And also consider costs, response times, and how to monitor for errors. So like really, if you have to have low cost or you have to have really fast response times, you likely cannot use the biggest models. Or like in the new O3 mini case, you have to configure it to use less reasoning. So you have 3 different levels of reasoning in O3 mini. So you likely want to use the smallest. And also try to figure out a feedback loop. So how can you actually get feedback from your users without any effort on their side so you can improve the system? And this is often an overlooked aspect, which is a cross-department effort. So you often need the designers, front-end engineers, product managers involved to actually figure this out. How can you actually set this up? But this will probably be the most important step, because data advantages and feedback loops are probably the biggest advantages you will have in software in the future. And then it's take the stuff we talked about, like for context engineering, like curating input signals, give it a structure, refine it, balancing the breadth and precision. So basically treat the context window as precious. So every token counts and don't throw everything in there. Actually spend some thought what should be in there and what shouldn't. And also don't be afraid to take away. I think like the default knee-jerk reaction most of us have is like when a prompt isn't working, add more instructions, add more stuff. Sometimes also like removing irrelevant instructions or redundant instructions already helps a lot. And if you want to move in like the entire knowledge graph space, I think a knowledge graph is really complex if you want to get it to work. So if you want to construct a knowledge graph, I would first start with metadata. So a knowledge graph, usually you already have a vector search in place. So I would first start with metadata and start tagging the different items. For example, I would use an entity extraction to identify the key elements in the text, people, organization, events, concepts, but make it really use case specific, like what's relevant to your specific use case, because then often you don't even need a really good entity extraction model, but you can get away with regex matching. Like if you have a set of entities which are really important, take those and do a regex match on the different texts and actually put it into an additional metadata column called tags. And this you can use for pre or post filtering. And with this, you can avoid the additional complexity of using a knowledge graph in the beginning as you're building out your general capabilities. And after that, you actually can start to think about, okay, what are the different relationships of the different entities? What entities should we add? And this will take a while, and I would always start really small. Make it really specific to one use case, focus on the key relationships, the key entities you face there, add them, create a knowledge graph, and then expand it as you go. I'm not sure the knowledge graph that AskNews has, which is ever expanding and has an infinite size potentially. I don't think for most use cases this is the right way to approach it, because you're likely building something really specific. And so you should actually make the knowledge graph specific for your use case as well. At least that's my opinion. And lastly, I think like the advanced querying, like using graph query languages like Cypher or Gremlin or Turtle, I think in the beginning it's a waste of time to even touch that. Construct your graph, store the relationships in whatever database you are using at the moment. So use Quadrant, use Postgres, and when you hit a point where you actually use the knowledge graph this much that it becomes a performance limitation, then you can start to think about, okay, I need something more custom. But I would always opt for something like the simpler solution, especially in the beginning, if you don't really know, is the knowledge graph. Will it work and will it have a benefit on my application? You don't want to over-engineer it. You want to test it with as low effort as possible and with really low complexity. So figure out a way to actually add it to the databases you're at the moment already using, and you can integrate a knowledge graph in like nearly every storage format or data. So make your life a little bit simpler, because in the end, the biggest waste of time, if you spend like weeks figuring out like knowledge graph databases and graph query languages, and then you don't even use it because you just saw all the advanced querying is just a waste of time, or it's like too much for your specific use case. Yes, this was my podcast with Rob. So if you listened until here, I can just ask you, leave a review, leave a comment, especially on Spotify and Apple, but also on YouTube. It helps out a lot. Also, if you have any topics you would like to hear more about, let me know in the comments below. Otherwise, I will catch you next week when we will continue with more on knowledge graphs.